Welcome to tonight's video on section 2.5, talking about finding the zeros of polynomial functions. Today we're going to talk about finding the zeros if you're not given one of them right away. And the way we do that is to come up with a list of possible numbers that could be zeros, and to do that we use what's called the rational zero theorem. And basically what that says is if you have a function and it has integers, coefficients, and basically you know that p over q is going to be a rational zero, where p is a factor of the constant and q is a factor of the leading coefficient. So to put that into kind of simpler terms, if I was asked to make a list of all the possible zeros of this function, the p term is going to be the 4. The q term is the leading coefficient of -1. Alright, that's the first thing you got to understand. Now, to make a list, I'm going to list all the factors of the p term. Well, all the factors of 4 are plus or minus 1, 2, and 4. Because remember, 1 and -1 are both factors of 4. 2 and -2 are both factors of 4. 4 and -4 are both factors of 4. So don't just put 1, 2, and 4. You got to put plus or minus because the positive and negative numbers are factors. Of q, it's just plus or minus 1 because 1 is the only factor of -1 as well as -1. Then what you want to do is make a list of all the ones if you divided each factor of p by each factor of q. So for example, 1 over 1 is 1. 2 over 1 is 2. And 4 over 1 is 4. So basically I took each factor of p and I divided it by each factor of q. Well, in this case, since there's only plus or minus 1 as the factor of q, notice the list of p over q was the same as p. So these are all the possible zeros for this function. So we'll try another one. Here, remember, p is -6, q is 1. So the factors of -6 are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. The factors of q, the leading coefficient, is just plus or minus 1. So we take each term in the p column and divide it by each term in the q. So 1 over 1 is 1. 2 over 1 is 2. 3 over 1 is 3. And 6 over 1 is 6. So the next example gives where there's a number in front for the leading coefficient. So p is the 2 and q is the 15. So the factors of p are plus or minus 1 and plus or minus 2. The factors of q are plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. Those are all the factors of 15. So when we do p over q, it's going to be a little different here. So we go 1 over 1, which is 1. 1 over 3, which is 1/3. 1 over 5, which is 1/5. And 1 over 15, which is 1/15. Then we go with the 2. 2 over 1 is 2. 2 over 3 is 2/3. 2 over 5 is 2/5. And 2 over 15 is 2/15. And those are all the lists of possible zeros of the function. Not all of them are going to be zeros. Those are the possibilities. So once again, let's try another one. So the q term is 4. The p term is -3. So the factors of -3 are plus or minus 1, plus or minus 3. The factors of q are plus or minus 1, plus or minus 2, plus or minus 4. So notice when we divide p over q, we get plus or minus 1, plus or minus 1/2, plus or minus 1/4. Then it's plus or minus 3, plus or minus 3/2, plus or minus 3/4. And these are all the possible zeros of the function. Now to find the zeros, the first thing we're going to do is make a list using our P over Q. So notice this is our P term, this is our Q. So P is plus or minus 1, 2, 3, and 6. And Q is just plus or minus 1. So remember, the P over Q is just going to be the same as P because all you're doing is dividing by 1. So that's our list of possible zeros. These are the possible zeros. Then we're going to use synthetic division to see if the possible zeros are actual zeros. So for example, I'll start with 1. And I'll do synthetic division on the function. Now remember, if it's a 0, I'm looking for 0 as the remainder here. This is the most important thing. Well, I bring down the 1, multiply, add, multiply, add, multiply. Notice I get -8, so that means 1 is not a 0. So then, you don't have to erase, I'm going to erase, but you're going to start and choose a different number. Choose -1. So then I bring the 1 down, multiply, add, multiply, add, multiply. Notice I get 0 as the remainder. That means -1 is one of the answers. Let's keep that in mind. Now the key thing is, remember, I'm left with the resulting polynomial of x squared plus x minus 6. So what I need to do is either factor or use the quadratic formula to find the remaining zeros. So notice this factors to x plus 3 and x minus 2, right? Because the factors of -6 which add to 1 are 3 and -2. So when you solve this, you get x equals -3 and x equals 2. So my three zeros are -1, -3, and 2. Those are my three zeros of this function. And notice, those are all on the list here of possible answers as well. So let's try again. Find the zeros here of the function. So P is 20, Q is 1, so the factors of 20 are 2, 4, plus or minus 5, plus or minus 10, and plus or minus 20. Factors of Q are 1. So that means P over Q is just going to give you plus or minus 1, 2, 4, 5, 10, and 20. So then I do the synthetic division. I start with 1. Bring down the 1, add or multiply, and then add down, multiply, then add down, and multiply, add down. Notice it gives me a 0, so that means 1 is one of the answers. The resulting polynomial is x squared plus 9x plus 20. So then I'm going to factor that. So I get x plus 5 and x minus plus 4. And that means when I solve these, I get x equals -5 and x equals -4. Those are the remaining two zeros of the function. So in all, I have 3. So go ahead and try this one on your own, and then I will explain this one as we go along. No, I have. It's taken. I'll ask him because I don't know. Is there batteries?
If it's a triple A, I have some in my office.
I think it
If it's
is.
double A, I don't. And if it's something else, I don't.
It's triple
Oh, I have some in my office. How many?
A. 2.
I mean, I don't know if it's that or if it's just a little loose.
No, I
But
think it is
I
that
have to
probably.
kind of do things twice and it doesn't always respond real fast. I just turned it off.
Because the laser pointer doesn't work either.
Oh, so maybe let me give you 2 new batteries and see if
Okay.
that helps.
Yeah.
Thank you for leaving me the cord.
Oh, no problem.
And you were able to use one, right?
Yeah, yeah. I put it back in his office. It works out. Thanks for getting that. So if you notice, when you do the work here, and you find the zeros are 1 and 3, and you do the synthetic division, only -3 works. Notice -3 is the only one that gives you 0. So then you get this resulting polynomial here, and notice you can't factor it, so you'd have to do the quadratic formula. So a equals 1, b equals 4, c equals -1. So you go -b plus or minus the square root of b squared minus 4ac all over 2a. So you have -4 plus or minus the square root of 16. -4 times 1 times -1 is positive 20, or sorry, positive 4. Over 2. So then you have -4 plus or minus the square root of 20 over 2. The square root of 20 can be simplified to 2 square root 5. And then remember, you can simplify that even further because there's a common factor of, you can take out a -2, and it's a common factor of 2 plus or minus square root of 5 over 2, which means you have -2 plus or minus the square root of 5. And that is the zeros. So the zeros are -3 and then -2 plus or minus square root of 5. Those are the 3 zeros. All right, that concludes our video for today. If there's any questions, please feel free to ask in class. Have a good evening. Thanks.